Next little bit, talking about making cations and ionic compounds. The ionic compounds just thrown in because it's very, very important that you're familiar with polyatomic ions, with all the different types of ions. So electron configuration of Fe2+. So we take iron and we're going to remove 2 electrons from it. Well, before we remove the 2 electrons, let's look at its electron configuration. So start off with argon, and then we're into the 4 S's. 2 of those, and then 3 Ds and 6 of those. I'm not going to dwell on that because we dwelled on those quite before. Now we remove 2 electrons. Well, which 2? The unthinking person would say, well, let's take 2 away from the 3D. But the thinking student says, no, you remove electrons from the highest shell. So we're going to remove those 2 electrons from the 4s, giving us argon 3d6. Answer D. And how many unpaired electrons in an ferric ion, otherwise known as Fe3+, or iron 3? Well, we already know what iron 2 is, so therefore to remove a 3rd electron we get argon 3d5, because now we've got to remove it from that 3d. Think about that 3d. How do we put 5 electrons in? And the answer is we put them in separately. So therefore we put 5 in the 5d subshells. So therefore there are 5 unpaired electrons. Consider the set of isoelectronic atoms and ions, which arrangement of relative radii is correct. Well, if they're isoelectronic, that means same number of electrons, and the size increases as the ions become less positive or more negative, because the size increases, same number of electrons, therefore you look at the protons, and the fewer protons you have, the less tightly the electrons are being held, so the ion will get bigger. So therefore, this is the biggest one. A2 minus, E2 plus is the smallest one. Less positive, more negative, more positive, the smaller. Which ions larger in each pair? Looking at the periodic table. So we've got oxygen or sulfur. Well, everything to do with sulfur size bigger than oxygen size, so S2 minus is bigger. Now let's look at iron right there, 2 plus or 3 plus. Well, what we got here is the same number of protons, but the more electrons that we remove, the more tightly the nucleus is going to hold on to what is left. Generally, cations are smaller than their atoms and get smaller the more cationic they get. So that means Fe2 plus is going to be the bigger, Fe3 plus the smaller. And now we'll look at S and potassium. Both of these have 18 electrons. Okay, S2 minus, there we are, 2 minus takes it up to argon. K plus, remove an electron, takes it to 18 electrons. Isoelectronic size increases, the ions become more negative, so therefore the more negative one, S2 minus, is going to be the bigger one. So we've got S2 minus, Fe2 plus, S2 minus, answer A. Now we'll move to naming ionic compounds. Really, really important you can do this. So let's see. Copper 2 is Cu2 plus. Bromide you've got to know is Br minus. So we're going to have 2 minuses to go with the 2 plus. So therefore we need 2 bromides. Silver Ag plus. Carbonate CO32 minus. You've got to have 2 of the Ags to go with the 2 minus of the carbonate. So that looks pretty wrong to me, but let's keep checking. Iron 2 is going to be Fe2 plus. Sulfite you've got to know is SO3 2 minus. Sulfate is SO4 2 minus. Turn the 8 to an 8, you remove an oxygen. Aluminium is Al3 plus. Phosphate PO4 3 minus, so 3 plus balances 3 minus quite nicely. That looks good. Magnesium 2 plus, hydroxide 1 minus, so you're going to need 2 of the minuses to balance out the 2 plus. MgOH twice. Names of these, just got to know it. This is an atom, a sulfur atom that you've made into an anion. Whenever you make an atom to an anion, you use its ide format, so sulfide. ClO4 minus, you've got to know, is perchlorate. NO2 minus, well, it looks like NO3 minus, which is nitrate. As I said earlier, turn the 8 to an 8, and it goes from NO3 to NO2. Charge stays the same. Protons, neutrons, electrons in barium cations. So here we're matching up the end with the start. So let's see what we know. Okay, here's barium down there. It's got 56 protons. Okay, so Z is 56, so we can eliminate immediately answer D where it's saying 58. Okay, now ordinarily in an atom there would be 56 electrons, same as the number of protons, but we've got 2 plus, so therefore we've lost 2 electrons, so therefore we've got 54 electrons. So we want something that's got 56 and 54, so now we're either B or E, 56 protons, 54 electrons. Now let's get the neutrons. Okay, neutrons plus protons is of course that mass, 136. So the neutrons is the 136 minus the number of protons, which is 80. So we've got 56 protons, 80 neutrons, and 54 electrons. Answer B. Same electron configuration, i.e. same number of electrons. Okay, well there's chlorine and sulfur, Cl minus, goes from 17 to 18 electrons. Sulfur only has 16 electrons, that's not the same. Krypton and argon have the same number of valence electrons, but not exactly the same electron configuration. Okay, krypton has got 36, argon has 18. Cl minus and Ca2 plus, well as Cl minus would have 18 electrons. Ca2 plus starts with 20, loses 2, goes down to 18, so 18 electrons. So that looks good, but continuing on, aluminium and phosphorus, Al3 plus, 13 goes down to 10, P3 minus, 15 goes up to 18, and finally K has got 19, K plus would have 18, so therefore which have the same electron configuration, C, the isoelectronic chloride and calcium cation. Prefix bi added to anion names to indicate an extra positive hydrogen, so bicarbonate compared to carbonate, which is volume anion has been known as bisulfate, or sulfate is of course SO4, 2 minus. Well, we need now for bisulfate an extra positive, so that would be SO4 minus, but then an extra hydrogen, so HSO4 minus. D. Finally, chemical formula magnesium phosphate, magnesium Mg2 plus, phosphate PO4 3 minus. So we do a little cross multiplication. We got to have 2 of the phosphates for 3 of the magnesiums, thus E. And I lied, I said that was the last question. This is the last question, just got to know these. Carbonate, CO3 2 minus, sulfate, SO4 2 minus, phosphate, PO4 3 minus. Oxide comes from oxygen. Oxygen needs 2 electrons, so therefore oxide is O2 minus.